In lots of your classes in this program, in fact, probably in all of your classes, at some point you talk about color. So we're going to just do a little bit of a review on some basics on color, and then we're going to start talking about color in a very different aspect in terms of the pre-press aspect of your files. As you know, our color wheel is the one on the left here, where we have our three primary colors, red, blue, and green. They're called additive colors, and they're called that because you're adding light together to make other colors. This creates our whole visual spectrum. This is how we see light. It has been proven scientifically for since like the 40s that no question this is the actual primary colors we're dealing with. Now, the subtractive colors are in essence the opposite because now we've introduced substrate. And we've talked about paper, and we've entered that into the realm. So subtractive colors are what the paper absorbs one color and then it reflects the other two colors, and that's how we see things that are printed. You'll notice that if you combined 100% of all of the additive colors, you get white. If you combine all of the 100% of magenta, yellow, and cyan, you get black. The reality is you don't get black. You get this muddy, muddy brown. So they introduced black as a fourth color to print with based on the subtractive color theory. And so that's where the two different gamuts that we deal with primarily as designers, which are the additive colors and the subtractive colors. The important notion is that the combination of all of these colors equals a neutral. And neutral is kind of our goal when we're doing any kind of color correction. Now, monitor, calibration, and characterization those are two different things, okay? When you have software that will profile different devices, okay, it can both calibrate and characterize your monitor, okay? Calibrating means you're going to bring it into compliance with a predefined standard of some sort, okay? So the graphic design or graphic arts standard white point is they use a 5,000 degree Kelvin. Okay, so that's the target for your white when you're calibrating. Characterizing your monitor creates the profile that describes how your monitor is displaying or reproducing the color. Okay, so monitor calibration involves both. You have to adjust the brightness and contrast and the overall level and range and intensity of your display to that target, and you come up with a profile that you can then use that is going to be accurate. Okay? When we talk about gamma, we talk about the brightness of the midtone values. Gamma equals midtone values. The values that your monitor from a black to white, okay, if you graph it, it's not linear, it's on a curve, okay, and the gamma defines the value of that curve as it falls halfway between black and white. The white point is the color and intensity of the brightest white the monitor can reproduce. An interesting exercise is to take the loop out of your kit that you got and put it on your screen on this white part of the paper and see how many white lights you see in there. I'm going to go with 0. Now, color space is how we define a color, okay? We can define a color as a CMYK value. We can define it as a Pantone value, or Pantone Matching System, PMS. Spot color. We can define it as an RGB. We can define it as an LAB. We can define it as any given space of color that has its own gamut. What we can't do is combine color spaces. In other words, we can't define a color as having 100% cyan and 132 green. The Pixel doesn't know how to do that. It has to be in one color space or another. Pantone it's all about ink, okay? When we print, we have our process colors: cyan, magenta, yellow, and black. Sometimes, if we can't reproduce a specific color accurately using those values that we're printing with of CMYK, we may choose to print using a Pantone ink or a spot color ink, a special mix ink. Okay, Pantone is the most common system that's used worldwide about ink. And what happens is you have to have a separate unit on the press, and the ink that goes in that is that color. In this case, it would be that purple, because the closest we can get to representing that Pantone purple using CMYK that we are now displaying on an RGB screen, okay, or even worse, one step removed down here, okay, here is the color that we get to this using a CMYK. If this was your logo color and this is what you wanted, if this was your logo color and what you wanted, this would not be acceptable. Now, the reality is this isn't accurate either. That's why we have Pantone guides, and when we hold the Pantone guide up next to the color that we may have mixed using CMYK and we're viewing it on an RGB screen, and then this is the actual spot coloring, you're going to find that none of them match. Okay, so what we have to do is we have to take the Pantone guide to our customer and say, this is the color this purple will be, because there's no way to proof a Pantone color. A color gamut is device dependent. Each device has its own gamut that it can reproduce. Okay, there are inputs and outputs. Okay, when you look at a monitor, you've got the information that you can put in, and there's a maximum amount of information that the monitor can handle, and then when it outputs, there's a maximum number of information it can output, and then your eye is going to see it however your eye is going to see it, depending upon your own color gamut of your eyes. Now, the visible spectrum, we call this the shark fin. The visible spectrum is this outside. That's all the colors that you can see. You'll notice that each of these gamuts is different size than what we can visibly see. This is what we can reproduce. Okay? Some of them are larger than others, but then you get into accuracy problems. Notice the colors that are the hardest to reproduce are the greens and blues and purples. They fall outside the gamut. Now, a color profile, which we're going to talk more about, a color profile is a translator. Okay? We have RGB values that we have on our file. And what we want is we want to have something interpret that RGB and give us the very best CMYK reproduction of that RGB that we can get. Our input, our source is RGB. Our destination or output is CMYK. Two different color spaces, both device dependent. What we need to do is we need to have some sort of an innocent, uninvolved bystander that can mathematically say, okay, I'm going to take this RGB value and I'm going to translate it into the CMYK that I'm going to reproduce. And that translator is LAB. And LAB works on a three-dimensional form of defining color, and it does it regardless of the device. It is device independent. Okay, you'll learn a lot more about color in the color class. The profile is the key to getting the best translation. Okay, now Photoshop, when you first open the program and you go to your color settings to see what kind of working space it's using with, it ships with sRGB. And that's because it's the lowest common denominator for the whole world. Okay, if you read the description down here, it isn't for print. Okay, it's endorsed, it's the default for many scanners, low-end printers, and software applications. Ideal space for web work, but not recommended for pre-press work because of its limited color gamut. It's the one they ship with because it's the lowest common denominator. Okay? One of the first things you're going to want to do is set your color settings, and you're going to do that by getting rid of this one, and we'll talk more about that. Because we deal with all of the Adobe programs primarily, we want to make sure that we have consistent color settings from application to application. To do that, if you open Adobe Bridge and you go into your color settings, if you select the color setting that you want here, it will apply this to all of your other applications. You have synchronized pie. You do not want broken pie. If you set this and then you go in to Photoshop and you change your color setting to something else for that particular moment, and you come back to Bridge, you're going to find you have broken pie, and that's saying that you're not using the same profile for all of your applications. Because we deal with all applications in pretty much each of our files, we want to make sure we're consistently using the same profile setting.